In this video, let's talk about how to find a term in the geometric sequence given any two terms in that sequence. Here we have the second term of a geometric sequence is -12, and the first term is -108. What is the seventh term of this sequence? Because this is a geometric sequence, let's write down the general term of the geometric sequence. The nth term of the sequence a(n) equals to the value of the first term a times the common ratio r to the power of n minus 1. So this is the general term of the nth term of a geometric sequence. We need to evaluate the seventh term, but at this moment we don't know the value of a or r yet. So we need to figure out the a and r first. Then we can use this general term to solve the seventh term. So how do we figure out a and r? We were given two terms, the second term and the fourth term. Okay, so now let's apply the general term to these two terms. For the second term, we know that n equals to 2. Using this general term, we know that a2 equals to ar to the power of 2 minus 1. We know that a2 equals to minus 12. Then on the right side of this equation, we have ar to the power of 2 minus 1, which is to the power of 1. R to the power of 1 is just r, so we can erase this 1 here. So we get our first equation. This is our first equation. But we can't solve two unknowns with only one equation. Then let's try to set up our second equation using the fourth term. For the fourth term, we know that n equals to 4. Then we can write the term as a4 equals to ar to the power of 4 minus 1. We know a4 equals to minus 108 equals to ar to the power of 3. So this is our second equation. Now we have two equations. We can solve two unknown variables, which are a and r. How do we solve it? We'll use the division of these two equations to eliminate one of the variables. This will allow us to solve for the other. Okay, let's divide equation 2 by equation 1. On the left side, we have minus 108 divided by minus 12. On the right side, we have a times r to the power of 3 divided by a times r. Now you can see that we can cancel a from both numerator and denominator. Also dividing the numerator and denominator by r will leave us r squared. So on the right side, we have r squared. On the left side, we have minus 108 divided by minus 12 is 9. Then we can solve for r by taking the root of 9. Pay close attention here. Don't forget this plus minus sign, which means we actually have two solutions. The even roots have two solutions. If the index is odd, then you have only one solution. For example, if p cubic is 8, that means p equals to cubic root of 8. Then it equals to positive 2. If p cubic equals to negative 8, then p equals to cubic root of negative 8, which equals to negative 2. So if this index is odd, that means you have only one solution. Alright, let's erase this and return to the question. So we have two solutions for r. R is positive or negative 3. Then we can plug in the value of r into either the two equations. Let's just use equation 1 here. When r is positive 3, we have negative 12 equals a times 3. We can divide both sides by 3. Negative 12 divided by 3 is negative 4. On the right side, only a is left because 3 divided by 3 is 1. So we get a equals to negative 4. Similarly, when r equals to negative 3, we have negative 12 equals to a times negative 3. Then we divide both sides by negative 3. On the left side, we have negative 12 divided by negative 3, which is positive 4 equals to, and on the right side, only a is left because the negative 3 on the numerator and denominator are cancelled. Now you can see that we have two solutions. When r equals to 3, a equals to negative 4. When r equals to negative 3, a equals to positive 4. Now we can write the two general terms based on the different values of a and r. For case 1, so this is our case 1. This is case 2. For case 1, we get a n equals to, a is negative 4. We just plug in negative 4 here. R is positive 3 to the power of n minus 1. This is the general term for case 1. For case 2, we have a n equals to, a is now positive 4 times negative 3 to the power of n minus 1. Now that we have our general terms, we can evaluate the seventh term for these two cases. For case 1, when n equals to 7, we have a7 equals to negative 4 times 3 to the power of 7 minus 1, which equals to negative 4 . So it equals to negative 29, 16. For case 2, a7 equals to 4 times negative 3 to the power of 7 minus 1. So we have 4 times negative 3 to the power of 6, which means the answer is positive 2916. Well, let's try writing out these two sequences. If we start from negative 4, which is the value of a, and a common ratio of 3, then the second term will be negative 12. The third term will be negative 36. The fourth term will be negative 108. The fifth term will be negative 324. The sixth term will be negative 972. And the seventh term will be negative 2916. And you can see that all terms have negative values. If we start from positive 4 with a common ratio of negative 3, Then the second term will be negative 12. The third term will be positive 36, because negative 12 times negative 3 turns into a positive number. Then the fourth term is negative 108. The fifth term is positive 324. The sixth term is negative 972. And the seventh term will be positive 2916. In this case, you can see that the successive terms alternate in sign. These even number terms are negative, and the odd terms are positive. Therefore, we have the second term and the fourth term as negative 12 and negative 108. But the seventh term is positive 2916. Now you can see that we have two sequences where the even number terms match, but the odd number terms don't. So this is why we have two solutions for the seventh term, which is an odd number term.